I'm Anil Kumar. Welcome to my series on sharing with you some amazing questions. In this video, we are talking about three important questions. First is to factor unfactorable n to the power of 4 plus n square plus 1. Then we will write n over n to the power 4 plus n square plus 1 as sum and difference of two fractions. And finally, we are going to evaluate the sum of this series, which is from 1 to 100, n over n to the power of 4 plus n square plus 1. This is extremely important video for students who want to really excel and compete at different levels. So let's begin with factoring. So we'll first factor n to the power of 4 plus n square plus 1, right? You will realize that this particular trinomial is always greater than, or it is, we can say, greater than equal to 1, correct? Since this factor is greater than equal to 1, it has no x-intercepts. So that means normally we'll say, so we say it is, we categorize them into unfactorable, right? Since it has no real roots, right? Unfactorable since it has no real roots. Now definitely we are going to factor it. So using the term unfactorable is not correct, right? But we can say it has no real roots, right? That is kind of important. So what we understand from here that we can actually factor it. So how do we factor such trinomials? The technique is completing the squares method with difference of square. So whenever you get into such a situation where you need to factor trinomials, then you can always use this technique of completing the squares and then difference of squares. We'll see how, right? So what we see from here, n to the power of 4 plus n square plus 1, we could actually make it a perfect square by adding and subtracting n square. We'll get 2n square, right? So we know that n to the power of 4 plus 2n square plus 1 is a perfect square, right? So what we will do here is that to this trinomial, we are going to add and subtract n square. So that gives us n to the power of 4 plus 2n square plus 1 minus n squared. Do you see that? Now this term here is a perfect square, and that is what we call completing the squares, right? So we get this as n square plus 1 whole square minus n squared. Do you see that? So this is our step which helped us to complete the squares. So by adding and subtracting n squares, we actually completed the squares. Do you see that? Now what we get here is difference of square, right? We know a square minus b square can be written as a plus b times a minus b. So now we have difference of squares. We could write this as n square plus 1. This is n square, right? So we'll add and subtract n. N square plus 1 minus n. Do you see that part? So what we get here is a factored form of our trinomial. Perfect. So if you want, You can also rewrite this as n square plus n plus 1 times n square minus n plus 1, correct? So that is the factored form for the given trinomial. Do you see that? Now we'll use this factored form to write n divided by n to the power of 4 plus n square plus 1 as sum or difference of two fractions. Perfect. So remember this, we have factored our trinomial and we have written this as n square plus n plus 1 times n square minus n plus 1, correct? So let's move forward and take part 2 of this exercise. So now we'll write this rational function as sum or difference of two fractions. So let's begin with n over n square, n to the power of 4 plus n square plus 1. We have just written this as equal to n, and the factored form of the denominator is n square plus n plus 1 times n square minus n plus 1, correct? Now we need to write this as a over one factor, which is n square plus n plus 1, plus b over the other factor, which is n square minus n plus 1. Now, if we actually see this, if you add these two, what do you get? If we add these two, then we get 2n square plus 2. But if you subtract, then n square plus 1, n square plus 1 cancel and we get 2n in the denominator, right? So subtraction of this gives you 2n. So that gives you an idea that we could actually write this as something like this. Half of 2n times n square plus n plus 1 times n square minus n plus 1. Right? So we could write this as this. Now, this 2n can be written as a combination of these two subtracted, correct? So we could now write this as half of n square plus n plus 1 minus n square minus n plus 1 over n square plus n plus 1 times n square minus n plus 1. Is that clear to you? We found that when you subtract these two, you get 2n, and that was the idea of dividing this by 2 and multiplying by, right? So now we get our fraction, right? So we could write this over that, right? So we could write this as half of the first term here is n square plus n plus 1 divided by product of these two times n square minus n plus 1 minus half of n square minus n plus 1 divided by product of these two n square plus n plus 1 times n square minus n plus 1. Correct? Now this factor cancels and you're left with 1 over. So we can write 1 over. So this is, these two cancel, right? Plus 1 terms cancel. Here the minus 1 cancel, right? So what you get is 1 over 2 n square minus n plus 1. And here you get half of n square plus n plus 1. Do you see that part? So that is how we get this as a difference of two fractions. Perfect. Now we are going to use this particular identity. We could also write this as, well, half common as it was, right? and that is to say 1 over n square minus n plus 1 minus 1 over n square plus n plus 1, correct? So you could also write like this, and using this we are going to find the sum of our series of 100 terms. I hope you appreciate it, correct? Now once we have learned a lot about this trinomial and also how to split the given rational function into partial fractions, it is easier to find the sum. So let's rewrite this with what we have just done, and from 1 to 100, n over n to the power of 4 plus n squared plus 1 is really equal to the sum of the series from n equals to 1 to 100, and we wrote this as half of two fractions, right? 1 over n squared minus n plus 1 minus 1 over n squared plus n plus 1, correct? So that becomes our series now, and we'll see how to find this sum, right? Now half is independent of this, so we can always take half outside this bracket. So we can write this as half of sum of n from 1 to 100 of our series, which is 1 over n squared minus n plus 1 minus 1 over n squared plus n plus 1, correct? Now in this series, when I substitute 1, what happens? So if I substitute 1 here, I get 1 minus 1 is 0. I get 1 over 1, right? So what we get here is half of, now let's substitute n equals to 1, 2, 3, 4 and see what we get. If I substitute n equals to 1, we get this as 1 over 1 minus, substituting 1 here gives us 1 plus 1 plus 1, that is 1 over 3, right? So we get minus 1 over 3. So that is for n equals to 1. And now we are going to add what is when n is equal to 2. So when you substitute 2 here, 2 squared is 4, 4 minus 2 is 2, 2 plus 1 is 3. So what we get here is 1 over 3 minus, substituting 2 means 4 plus 2, 6 plus 1, 7. So we get 1 over 7. Now, if I substitute n equals to 3 here, 3 squared is 9, minus 3 is 6, plus 1 is 7. So we get 1 over 7 minus, substituting 3 here, 9, plus 3 is 12, plus 1 is 13, right? So what we get here is 1 over 13. So as you can clearly see, this series continues, right? The last term will be when we substitute this as 100. So when I substitute 100 here, so we get 100 square is 1000, right? 1000 minus 100 is 9900 plus 1 is 901. So we get 99 or 1 here minus. Now if I substitute 100 here, we get 1101. So we get 1101, correct? That's what we get. Now when you add this series, you can clearly see that all the terms in between cancel. Do you see that? So likewise, all will cancel. What remains is these two terms. So the sum is now very clear. It is half of 1, right? Let me write 1 over 1 itself minus 1 over 10101, right? So which is half of, now we have 10101 minus 1 over 10101, right? So which is half of 1, take away this one, so 100 over 10101. And you can divide this by 2 to get your answer, which is equal to 50, 50, which is equal to 50, 50 divided by 10101. Perfect. So that is how we get the solution of this particular series. So sum of this series is equal to 50/50 divided by 10/10/1. So I hope you understand and appreciate how we could solve such complicated series. So the idea here is to understand how to factor these trinomials, write them as partial fractions, and then have a relook at your series. Most of the time, most of the terms will get cancelled and you will get the answer without even using the calculator. So I hope that really helps. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.